Alright, today we're going to talk about using various postulates and theorems to prove triangles are congruent. We're not going to actually write the proofs today, but we are going to talk about the different ways to prove triangles congruent. Before we dive into those things, we want to make sure that everybody understands a couple of keywords because they're going to be used a lot in these. In this picture over here, line segment AB is opposite angle C. Line segment AB is opposite angle C. They're on opposite sides of the triangle. And in a triangle, there's only three vertices, only three corners, and two of them are part of a side. The only one that's not a part of that side is the angle that is where the vertex for that angle is, that's opposite that side. So line segment AC is opposite angle C. So opposite's one word. And then line segment AB is included between angle A and angle B. If you talk about the included side or the included angle, it's the angle between the two things. So line segment AB is included between angle A and angle B. It's between those two angles. It's shared by those two angles. Okay, angle A is opposite line segment BC. Line segment BC and angle A are opposite each other. And angle A is included between line segments AB and AC. This angle is created by these two sides. It is part of, or those two sides are both part of that angle. That angle is between those two sides, included between. Alright, so if we understand those concepts, then hopefully we can understand these as we go through them. These are the different ways to prove that triangles are congruent. Now obviously, remember we talked about congruent triangles, all their corresponding parts are congruent. If you know two triangles are congruent, you know every corresponding angle is congruent, every corresponding side is congruent. If you can show that two triangles have all three pairs of corresponding angles congruent, all three pairs of corresponding sides congruent, then obviously you can prove triangles are congruent that way. What these provide is a way for us to prove triangles are congruent without having that much information. So these are giving us the minimum amount of information that you need to be able to know for sure that those two triangles have to be congruent to each other. Okay? So the first one is abbreviated SSS, and what that means is side, side, side. Okay? And that means that you found out that all three pairs of corresponding sides are congruent. If all three pairs of corresponding sides are congruent, then the two triangles are congruent. Not knowing anything about the angles yet, if we know that all three pairs of corresponding sides are congruent, then those triangles have to be congruent. There's no physical possible way for those triangles not to be congruent. So then once we know they're congruent, then we'll know the corresponding angles will also be congruent. But we don't have to know that ahead of time. We can prove that they're congruent just based on all the sides being congruent. Okay, SAS is side, angle, side. So this is another way to prove triangles congruent. If two pairs of corresponding sides and the included angle are congruent, then the two triangles are congruent. Now, the order of these letters is very, very important. You can't just have two pairs of congruent sides and one pair of congruent angles and be good. That pair of congruent angles has to be the included angles. They have to be the angles between the congruent sides. So notice in the picture, these sides are congruent, these sides are congruent. It has to be the angle between those sides, the included angle. It has to be those pair of angles that are congruent. If we didn't know these angles were congruent and we had some other pair of angles congruent, that would not work. The order here is important. The angle has to be between the sides. It's got to be the included angles that are congruent. Same concept on the next one. This is angle, side, angle. And once again, that order is important. The sides have to be the included sides. If two pairs of corresponding angles and the included side are congruent, then the two triangles are congruent. So notice you got two pairs of congruent angles, and it's the included sides that are congruent. So if we didn't know these sides were congruent and we had a different pair of sides congruent, that would not fit angle side angle. Okay? For it to be angle side angle, those sides have to be between the angles. Now, in this particular case, if it was a different pair of sides congruent, we would still have congruent triangles. If you turn the page, that is a different postulate. Angle, angle, side. So notice it's still two angles on one side. Still two angles on one side. The difference is the order. This time the side is not between the angles, so it is not the included side. If two angles and a non-included side of one triangle are congruent to the corresponding angles and non-included side of another triangle, then the triangles are congruent. We got the same two pairs of congruent angles, but it's no longer the included sides that are congruent, it's non-included sides, sides that are not between those angles. So that's angle, angle, side. And then we got one more. It's a special case. Ignore that these pictures are not very good. Apologize for that. This is hypotenuse leg. This is the only one that does not fit that same kind of formula as all the others. It's the only one that doesn't just have A's and S's for angles and sides. And this is a special case that only works for right triangles. Now, that doesn't mean every time you got two right triangles that hypotenuse leg is the way to go, but it means that you can only use hypotenuse leg on right triangles. It doesn't work for anything else, and that should make sense because only right triangles have a hypotenuse. You can't identify a hypotenuse on any other type of triangle, so this is only useful if you know you got right triangles. So here we got our pseudo right triangles because we acted like those are right angles by marking them right angles. If the hypotenuse and leg of a right triangle are congruent to the hypotenuse and leg of another triangle, then the triangles are congruent. So remember, the hypotenuse is the side opposite the right angle. So opposite the right angle is this side and this side. So the hypotenuses have been marked congruent. And then remember, the two sides that make the right angle are called legs. You just need one pair of congruent legs. Doesn't matter which pair of legs, one of those pairs of legs needs to be congruent. So while all the other things have three things you need, and this one only looks like it has two, you really have three because you also have the right angles. Remember, because it only works for right triangles. Only works for right triangles. Alright, so got several examples here, and in each of these examples, we are going to state the congruent parts. We're going to say how are the triangles congruent, meaning we're going to use one of those postulates and theorems we just learned. And then we're going to state the congruence. So we'll actually write the congruent statement for the triangles, remembering to keep those in corresponding order. So let's see what we got in the picture here. I see line segment AB is marked congruent to line segment DE. I see angle B is marked congruent to angle E. And I see line segment BC is marked congruent to line segment EF. Those are my three congruences. Notice I have two pairs of sides congruent and one pair of angles congruent. So two S's and one A. And notice the angle is between the two sides. So that is the included angle. So in the name, the A should be between the two S's, and we can say that these two triangles are congruent by side, angle, side. Side, angle, side. So that's how I know these two triangles have to be congruent, side, angle, side. So now I'm going to write a congruent statement. Now when I write the name of the first triangle, I can put those letters in any order I want. So when I'm naming this first triangle, it could be triangle ABC, ACB, CBA, BCA, however I want to put that. I'm just going to go pretty commonplace here and just say ABC. Now, once I've decided the name of the first triangle, though, that's going to determine the order of the second triangle. I have to make sure it goes in corresponding order. So, the ones I see are marked congruent are B and E. So those are the easiest. If B is the middle letter, E's got to be the middle letter, right? Now I also know that line segment AB is congruent to line segment DE. So I think the A and the D have to be corresponding leading into the B's and E's. So I'm going to put D here. And then line segment BC. BC corresponds with line segment EF. So I need the F over here. So there's the congruent statement saying that those triangles are congruent to each other. Alright, number 2. Let's mark everything that we see congruent, or write everything down that we see congruent. I see angle SPR is congruent to angle QPR. Okay, I see line segment PR is the same segment as the side length for both triangles. So we're using the reflexive property here. Line segment PR is congruent to line segment PR. And then finally, these two right angles are going to be congruent to each other. So I know that angle PRS is congruent to angle PRQ. So we have two pairs of congruent angles and one pair of congruent sides, so I'm thinking two A's and one S. And then I pay attention to the order. Notice that this side is the included side. It's between the two angles. It's included between those, so the S goes between the A's in the name as well. So that would be angle, side, angle. I know that these two triangles are congruent by angle, side, angle. So now I'm ready to write the congruent statement. I name the first triangle. I'm going to call it triangle PRS. And once I've determined the order of the letters for the name of the first triangle, that's going to determine the order of the letters for the second triangle. They got to go in corresponding order. Now the P from this triangle corresponds with the P from this triangle. R from this triangle corresponds with R from this triangle. So the only thing that we have to really work on much at all is the S corresponding with the Q. Alright, let's try number 3. Now, we got a bunch of stuff congruent here, so we could actually go different ways here. If I'm looking at just what's marked congruent, I got line segment EH congruent to line segment FG. I got line segment EF congruent to line segment HG. And I see these two angles marked congruent, so angle EHF congruent to angle HFG. Okay, so I see two pairs of sides marked congruent, one pair of angles marked congruent. Now, as it stands, we can't prove those triangles are congruent based on the information I just wrote down. It's got two pairs of congruent sides, one pair of congruent angles. We only had one postulate or theorem that had two S's and one A, and that was side, angle, side. But that would require the angle to be the included angle, the angle between these sides. So based on the three things I just wrote down, we can't get the job done here. We can't say that these triangles are congruent. However, we do know that line segment HF is being shared as a side length for both triangles. So I'm going to over here write down one more piece of information. That line segment HF is congruent to line segment HF. Now with that added piece of information, I could prove these triangles are congruent two different ways. I could do it by side, side, side. We have all three pairs of sides congruent now. So I could prove these congruent by side, side, side. Or, while this angle is not the included angle for these two sides, this angle is the included angle for these two sides. Right? So, we can do side, angle, side now. We do have an angle between two sides we know are congruent. So, either one of these would work in this situation. We have enough information to do either one. Now I'll write the congruent statement. I'm going to name the first triangle, triangle HEF. And in this triangle, angle H is congruent to angle F from the other triangle. So H corresponds with F, E corresponds with G, and in triangle HEF, angle F corresponds with angle H from the other triangle. Alright, let's look at number 4. Alright, let's label what we, or write down what we got marked congruent in the picture. We got angle V congruent to angle Z. We got line segment VX marked congruent with line segment ZX. And those are the only two things I see marked congruent. Now what we should recognize looking at the picture is we have a pair of vertical angles. Vertical angles right here. These two angles are congruent to each other. So they're both using the same vertex, so we can't just name them with one letter. So this is angle WXV, and it is congruent to angle YXZ. So now I got two pairs of congruent angles, one pair of congruent sides. So I should have two A's and an S. So now the question is it angle side angle or angle angle side? Because both of those have two A's and an S. The difference is it the included side or not? Well, this side does fall between these two angles. It is the included side. So the S needs to fall between the A's in the name, so it should be angle side angle that we're using here. And when I write the congruent statement, I can name this triangle in any order I want. I'm going to call it triangle VWX. So when I name the other triangle, I want to make sure it goes in corresponding order. The V would correspond with Z, W would correspond with Y, and then the X's correspond from each triangle. Alright, let's try this again on number 5. Practice, practice, practice. Repetition. We're going to try to get as comfortable with this as possible. Alright, well right now, I don't have anything marked congruent. I got some arrows on here. Remember, these arrows mean that these are parallel. The double arrows here mean that these are parallel, but nothing has been marked congruent. Now the first thing I can see is that line segment JL is being shared by both triangles. So using the reflexive property, I know that line segment JL is congruent to line segment JL. That's one pair of congruent sides. Now I got these parallel sides. How am I going to use that to find anything congruent? Well, some of y'all might find it helpful to extend the lines and see it more the way it was when we first learned it. We got two parallel lines. Here is a transversal. And hopefully you can see a pair of alternate interior angles. They're on different sides of the transversal, and they're in between the parallel lines. Those are alternate interior angles. So we can say angle MJL is congruent to angle KLJ. Now that was utilizing these parallel lines. We have another pair of parallel lines. These lines are parallel. Same transversal. Another pair of alternate interior angles. They're on different sides of the transversal again. And they're still inside those two lines, two parallel lines. Those are alternate interior angles as well. So we can say angle KJL is congruent to angle MLJ. And so now I got three congruencies. So most of the time 3 congruencies is enough as long as they're in the right places. I have 2 pairs of congruent angles, 1 pair of congruent sides, 2 A's and an S. So once again, I just need to check and see, does the side fall between the angles or not? Is it the included side? And this side does come between the angles. It is the included side. So the S should go between the A's. So this is angle side angle. So let's write the congruent statement now. We're going to call this triangle JML. And that'll determine the order of the second name. On this triangle, the J corresponds with the L from the other triangle. the M corresponds with the K, and from this original triangle, L corresponds with J on the other triangle. So there's our congruent statement in corresponding order. Alright, in the interest of time here, we're going to just skip down to the how the triangles are congruent. You'll notice here we got a pair of right angles. So these are right triangles. So the first thing I'm thinking, hypotenuse leg might be a possibility. Now remember, that doesn't mean hypotenuse leg is the answer yet, but that's a possibility because we got right triangles. The sides opposite the right angles are marked congruent. Remember, that's the hypotenuse. And then we have another pair of congruent sides. Remember, those sides are called legs. So these triangles will be congruent by hypotenuse leg. Okay, on number 7, I see one pair of congruent angles here, another pair of congruent angles here, and then I see a pair of congruent sides. So 2 A's and 1 S. So now the question is just the order. Angle, angle, side, or angle, side, angle. Is this pair of congruent sides, is that between the pair of congruent angles? No, it's not. It's not the included sides, so the S should not go between the A's and the name either. Angle, angle, side is how we're able to say that these two triangles are congruent to each other. Angle, angle, side. Okay, let's look at number 8. I see a pair of congruent sides. I see these two right angles. If they're both right angles, they're going to be congruent. Now, I only see those two things. I don't see anything else marked congruent yet, but I do recognize a pair of vertical angles. Vertical angles are always congruent to each other. So there's a pair of vertical angles. So now I have 2 pairs of congruent angles and 1 pair of congruent sides. So 2 A's and 1 S. Does the side go between the angles? Is it the included side? No, it is not. So once again, the side, the S, does not go between the A's. So this is angle, angle, side. Angle, angle, side is the way I am able to prove that these two triangles are congruent to each other. Alright, same concept we were doing at those last 3. Which postulate, if any, could be used to show the triangles are congruent? Well, here I got 2 pairs of congruent angles. Got 1 pair of congruent sides. So 2 A's and an S, that'll get the job done. So is the S included between the angles or not? Yes, this side is right between those 2 angles, so the S should go between the A's. I can prove these triangles are congruent by angle, side, angle. Alright, on the next one, I see these angles are congruent, and these angles are congruent. I don't see anything else marked congruent, but reflexive property, this segment's congruent to itself, and it's a side length for both triangles. So I have 2 pairs of congruent angles, 1 pair of congruent sides, and again, this side is the included side. It's between the congruent angles, so the S is going to go between the A's, and I know that these triangles are congruent by angle, side, angle. Okay, on C, these angles are congruent. These angles are congruent. I don't see anything else that's marked congruent, but I do recognize a pair of vertical angles. So I got those congruent. So I have 3 congruencies now, but they're all angles. I don't have any sides. So if I'm kind of following the pattern we would usually use, that would be angle, angle, angle. But if you remember, or if you look back at earlier in the notes, we don't have an angle, angle, angle. You'll learn later on that this will prove that the 2 triangles are similar when we start talking about similar figures, but it is not enough to prove that the triangles are congruent. So there is no way to prove that these triangles are congruent. Now there is a chance that they're congruent, but we don't have enough information to prove that they're congruent. So for right now, they're not congruent. Alright, mark the drawing to show the given information and fill in the blanks. Alright, well it says E is the midpoint of line segment KW. Well, if E is the midpoint of line segment KW, that means it bisects it, it splits it into 2 congruent halves. So I know that line segments KE and EW are congruent. And then angle KEG is congruent to angle WEH. So those angles are congruent. And then angle K is congruent to angle W. So, can I say that these two triangles are congruent? Yes, I can. I have two pairs of congruent angles, one pair of congruent sides. The side is between the angles, so I can use angle side angle to prove that these triangles are congruent to each other. So let's finish off the congruent statement. They've already given me the name of this triangle is KEG, so I want to make sure this goes in corresponding order. So the K corresponds with W, E corresponds with E, and then G would correspond with H. Alright, and the last one, number 11. Line segment FP, and it's kind of hard to mark on the picture because it's being split up, so FP is congruent to line segment HP, and angle F is congruent to angle H. And we want to prove that triangle PFS is congruent to some triangle, and hopefully you can see in the picture this triangle right here that it may or may not be congruent to. For some people, redrawing this picture is helpful. I'm going to separate these two triangles so we can see them separately. So here's triangle FSP. FSP. There's that triangle. And then we have this triangle right here, HPR. So there I've redrawn those two triangles separately so they're not overlapping. Now it's easier for me to label line segment FP congruent to line segment PH. We said angle F is congruent to angle H. Now there's nothing else that they told us is congruent. Nothing else marked congruent in the picture. But do you notice that the two triangles are sharing anything? What about angle P? Angle P is an angle for this triangle, and angle P is an angle for this triangle. And it's the same angle for both of them. Those angles are congruent to each other. So we are able to say that these are congruent. We have two pairs of congruent angles, one pair of congruent sides, so that's two A's and an S. Notice the side is between those angles. So angle, side, angle. Seems like we've had a lot of angle, side, angle going on lately. And now we want to write the congruent statement. Well, we got triangle PFS would correspond with, the P's correspond, F corresponds with H, and then S would correspond with R. So triangle PFS is congruent to triangle PHR by angle, side, angle.